can be for a lot of things.
Okay. So area and perimeter. Area is the two-dimensional space covered by a figure. Whereas the perimeter is the distance around. So when we think about area, we're thinking about what's taken up on the surface of the shape, in our case. And the perimeter is what's going on, or the distance that edges it. I think of perimeter as like fencing, and area is like the grass in the yard, okay? That flat surface that fills within the fence. So if we have this particular square here, a square has all sides congruent. That means that each measure is 4. So if I want to find my perimeter, I would add together all of those lengths. 4 plus 4 plus 4 plus 4. Or 16. And because perimeter is a one-dimensional measure, it's the length of the sides, when we label it, we just label it with whatever our units are. Feet, miles. If we have no unit, we'll put units on there. Whereas area is that space on the inside. And so each of these little boxes represents one area unit. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 spots on the inside. We can get that by multiplying the number of rows by the number of heights. Now, because it is a two-dimensional, we put a little squared on the end of our area. In this particular problem, it turned out that my perimeter and the area are the same. That's not unheard of, but it's not an always situation. So if I'm going to do the perimeter of this next shape, it would be 12 plus 12 plus 12 plus 12, or in this case, 48 units. But my area is 12 times 12, or 144 units squared. Please do the perimeter and area for number or letter C. Please do the area and perimeter for letter C. And I didn't mean to. Or I meant to, but I meant to turn it back on. Oh well. So there are our formulas for area of a rectangle in two different forms, area and perimeter of a square. So let's do the area and perimeter of this given rectangle. Start with area, length times width, base times height. We end up with 36 units squared. Perimeter is twice the length plus twice the height, or 18 plus 8, 26 units. What if I stick a variable in there? When you put a variable in it, it just makes it more algebra-like. It means that we're not committed to a measurement here. that could change. It could vary, hence the word variable there. But our formulas don't change. My area is length times width. The only difference is I can't get an exact answer. So I'll put my units squared at the end. And my perimeter is twice the length plus twice the width, which I can simplify to 24 plus 2x. I'll put parentheses around that whole thing so everybody knows it goes together. And then I put my labeled units on the end. All right, up next, parallelogram. Parallelogram is basically a rectangle tipped, okay? So when we look at a parallelogram, it'll look kind of like that. A parallelogram, by definition, has both pairs of opposite sides congruent and parallel. And so both pairs of opposite sides, I'd mark those as congruent with a straight dash, parallel with an arrow. Because a parallelogram, or a rectangle I should say, can be or is considered a parallelogram can be a rectangle, the formula is very similar. It's just that we have to worry about the height of the shape. And so when I'm looking at a parallelogram, I need to find a line in there that forms an altitude. That means it's got to come down from one vertex and form a perpendicular on an opposite side. That will be my height. The side that the right angle hits will be my base. So when I do my area, I'm going to still use the base times height formula. It's just that my base has to be in a different spot. So my area is base times height, or my height rather is in a different spot. It's not a length of a side. And they go through kind of the proof of what this looks like. If you look at a parallelogram and you cut that altitude off, you could slide that altitude over to the other side and you've just created a rectangle. So that's why their formulas are the same, but where you get your height from changes. It is not the length of the side, okay? So let's do a couple of problems. Because these are parallelograms, remember that opposite sides are congruent. So if I have a base of 8 and a height of 3, my area is just 8 times 3. Can I find the perimeter on this shape? Am I able to find the perimeter of this shape? No, because I don't know this angle measure. So I can't find the length of these missing sides that I have. So sometimes I need more information in order to find the perimeter of a shape. This one gives me a base of 8 and a height of 3. So here I have a base of 10 and a height of 4. Oops, I never did my math there, did I? So my area would be 10 times 4, or 40 units squared. Do you guys remember learning all these formulas before? Yeah? Okay. For example, 4, we're able to actually find the missing pieces. And so in this particular problem, I have a base of 12, but I don't have a height. I do know that this comes and hits a right angle. I could pull that little triangle out. And is there any way I can find that missing side? This one happens to be a Pythagorean triple, right? What if it wasn't a Pythagorean triple? What could I do? Pythagorean theorem, right. So we can go ahead and fill this in. Remember, this would be 4. It's a 3, 4, 5. That's one of our triples that are up on that board. But again, if I didn't remember that, I could do 3 squared plus h squared equals 5 squared. 9 plus h squared equals 25. H squared equals 16. So h is 4 when I do the math. Take the square root of both sides. All right, so let's go ahead. For here, I want the perimeter and area. This h is 4. Perimeter would be 2 times 12, that's the base, plus 2 times 5, that's the other measure of the side, or 5 plus 12 plus 5 plus 12, 24 plus 10, or 34 units. And my area would be base times height, 12 times 4, or 48 units squared. Pythagorean theorem isn't the only option for solving. We could use SOHCAHTOA, sine, cosine, and tangent. We can also use our special right triangles if we recognize them. So if I take this triangle out, if I know that this bottom here is 5, and it's a 45-45 right triangle, what does the height have to be? 5. What does the diagonal or the hypotenuse have to be? 5 times the square root of 2. So this is 5. This is 5 times the square root of 2. That 5 times the square root of 2 is going to be ugly in my formula, but it's still workable. Okay, so when I talk about perimeter, it is 2 times 18, that's my total base, they have it up here, 2 times 18, plus 2 times 5 times the square root of 2. Again, sort of ugly. But we'll just write that down as 36 plus 2 times 5 is 10 times the square root of 2. That's my full answer. I'll label it with units. Again, a little ugly to look at, but that's the exact answer, and that's the way I want it to stay. Then when I work through area, my area is 18 times 5, or 90 units squared. Okay, we're going to finish up with some odd shapes using the formulas that we have, but odd shapes. And when we work with these odd shapes, what we want to do is break it into pieces that are shapes that we know how to find the area of. So for example, there's more than one way to do this, but I could draw a line and create 2 rectangles. And so this first rectangle has an area of 4 times 6, or 24. And the second rectangle has an area of 4 times 12, or 48. So when I figure my area, I'll just add the pieces together to get my final answer. somebody next to you might draw their line in a different spot. That doesn't make where you break yours down wrong, it just makes it different. You see things different. We all visualize things different. So just try and come up with a spot that would be easy to work with. Also, sometimes when you draw your line in there, if I draw it, say, here, I have maybe the measurements very obvious for one, 8 by 6, or 48, but this other one is not so obvious, and I have to do a little bit of math. What is this top side of this rectangle? 14, because it's 20 full length minus the 6 there. So now I have a 3 by 14, or 3 times 14, what is that, 42? So my area would be 48 plus 42, or 90 units squared. Some shapes are going to be even more creative. And sometimes it might be easier to subtract an area from a total than it is to add the pieces together. So like, for example, on C, I could figure out this full area of a full rectangle here. That would be 11 times 5, or 55. And then subtract out that little rectangle there. Take out the piece that's missing. That would be a 3 by 2. So it's not always going to be adding stuff together. On occasion, it might be just as easy to subtract. Instead of making 3 little rectangles, I can just work with those two. 55 minus 6 would give me 49 units squared. So I'm open for some suggestions on letter D. Does anybody want to come and draw lines in here, take a look at it, make an adjustment, see how they want it to look? Or tell me where to draw a line? Jonathan.
Draw a line.
What's that?
Draw a line like cleaning the knife.
Here? Like here?
Yeah.
Okay.
Go.
Or this way?
Yeah. That.
This way. Okay, great. Perfect. Okay, so that gave us this shape here, 7 by 3, or 21. All right, now what else can I do? Go ahead. Yep.
Then do the thing lower.
Like here?
Yeah.
Okay. And that gives me this shape of 7 by 2, or 14. Okay, super. And then what's this middle guy? Nine plus 7 plus 6. So that full length here would be 9 plus 7 plus 6, or 20 what?
44. Oh, that would be 22.
22.
Yeah.
And then it would be 22 times 2, or 44. So my full area is 21 plus 44 plus 14. Add that all together, we get 79 units squared. Great. Okay. So let's do some other ones where we're actually going to be subtracting. These are our last of it. Find the areas of the shaded region. So again, these are going to be multiple steps. I want the area of the outer minus the area of the inner. So 10 by 6 gives me the full rectangle. Subtract out the square in the center. 60 minus 16. Is that, oops, 44? Great. Looking at B, does anybody have a suggestion for a setup for that one? Looking at B, how am I going to find my area? Serenity.
9 times 9, and then,
9 squared.
yeah. And then minus 6, 3.
Times 3. Perfect. So 81 minus 18. 63. Is my math okay? Okay. Good. One last problem. Looking for help on the setup on that one. Any thoughts? Okay, will that do it? And minus another 5 squared. Great. So 8 times 14, 112, I think. Minus 25, minus 25. Leaves me with 62, I believe. And don't forget your units squared. Okay, so today's homework, area and perimeter, rectangles, squares, parallelograms.